Okay. All right, so follow along, please. Bivariate data scatterplots. That's what we are up to for today's session. And this will be the last part for scatterplots after this topic. But then we'll go to something else and come back to it again. Okay? Because there is some other things we need to cover. But bivariate data scatterplots. All right. We ready? You all there? All right, cool. So let's go really quickly a recap of what did we do yesterday. Does anyone remember? It starts with T and has the letter S in it as well, and something to do with time series. Good. Anyone remember what they are? What's a time series? That's a graph. Good. What does it explain, Jonathan? Time series graph. Time intervals. All right, there's time intervals. Thank you, Jonathan. What does it explain? What is a time series graph? Change of data over time. Good. So it's time data that you record over time, and then you're recording the changes. Does anyone remember what this bit is called? Starts with L. Line. It's a line what? A line graph. Okay, it's a line and it joins all the dots. Okay, and that way you can sort of clearly see the pattern of data, what's happening to it. Yesterday we looked at this monthly ice cream sales as an example. One last thing, a couple more things. How do you interpret this? So what do we normally talk about when it comes to time series graphs? Okay, it starts with the letter T. It's like something to do with clothes. Trend. Good. You're talking about the trend. Whether it is, what's the word? Increasing or decreasing. Okay, those are the words that you want to use when you're talking about the trend of the data. Okay, and remember that on the x-axis of any graph is the time, and then the y-axis is whatever the other variable could be. You could be measuring height. You could be measuring the distance of something. You could be measuring how much money you made over a certain number of weeks. Okay, that's what goes here. Lastly, does anyone remember what this little bad boy is? Break. It's a break. What does it do?
It jumps from 0 to
Good. It skips numbers that you don't need to include. Okay, so if your smallest value, for example, in amount sold was 50, then you don't need to include 0 to 49, for example, because you don't need those numbers. Otherwise, your graph is going to look like this. And then your data's like up there. What's the point of including all of this data? There's no point. Yeah, you don't need those numbers. You're better off, okay, just cutting off some of it. Put a break in there so that you're skipping some of the numbers you don't need. Okay, that's what the break is for. Okay, well done, youngins. All right, now what we're going to get into is scatter plots. So we learned about time series, and we learned about how to plot those bits of data. Now we're going to learn about how to plot other types of data apart from time series. Okay, so a scatter plot is essentially the same as a time series. Yeah, it's the same as this, but you might have even more dots and it might be a bit more spread out. And there is no line. Oops. There is no line in a time series graph, in a scatter plot. Okay, in a time series graph, yes, put a line through your data, okay, that joins the dots. But in a normal bivariate data scatter plot, it's generally just a bunch of dots in a graph. So it might look something like this. Okay, there's an example of a scatter plot. Okay, that's what we're going to learn about today. Okay, so as our learning intention, what I'd like you to be able to do by the end of today's session, which you guys did very well yesterday, but for today is going to be producing a scatter plot of some sort. Okay, and then you're going to be comparing two variables. So remember with bivariate data, what does bivariate data mean, guys? Univariate means one, bivariate means two. Okay, you've got two datas, and you're maybe talking about the connection or the correlation is a key word between them. So if there is a connection between them, that's the focus for today. And by the end of today, I'd like you to be able to draw your scatter plots on an X and Y table. Remember, that's what we're looking at, the X and the Y axis. Okay, and you can describe the correlation between the variables and identify an outlier. Remember, outliers in univariate, what's an outlier? Something that doesn't match, so something that's really, really far out. So if I was to maybe record, okay, everybody's height versus their age here, okay, who might be an outlier?
You.
Why me? Because I'm really short and I'm really old, all right? So that means my dot in a scatter plot would be really far away from everyone else. Okay, that's what an outlier would be. Okay, so quick recap. Remember in semester 1, we learned about, actually no, it would have been this semester still. We did data last semester. Last term, thank you, Tony. We learned about univariate data, yeah? We looked at like measures of center, like mean, median, mode, okay? We looked at frequency tables, we looked at histograms, 5-number summaries, and box plots. Now, all of this relates to univariate, so one variable, because you're just looking at literally one thing or one piece of data and what it's telling you, okay? But now, as we are learning in bivariate data, it's a little bit different, okay? It's not one variable and more. In bivariate, there's 2 variables, okay? So we need to now, I want you guys to separate this from bivariate, because this is univariate. This is now bivariate data. You're looking at these sorts of tables and graphs, okay? You got your scatter plots. You got your X and Y tables like this. You guys have seen these before. You know, you lived and breathed that kind of thing. And then you've got what we're going to be building up towards is your linear graphs. Okay, linear, which means a straight line. Okay, so in bivariate data, you've got 2 variables. Okay, both of them are recorded in a graph. Okay, generally speaking, bivariate data always has a graph with it. So you've got this data, and then you have to translate it to a graph. That's what's going to happen. Okay, and this helps you. What it does is when you look at a graph, for example, if I was to ask you, can you tell me the relationship between both of the variables just by looking at the numbers? It's a bit tricky because it's just a bunch of numbers. But if you were to maybe represent it in a graph, you can probably say, oh yeah, there's something happening here. Every time it gets higher in temperature, for some reason there's more sales. Okay, it's easier to represent data if it is a graph like this as opposed to a table. That's why we do them in graphs like this. Okay, that's why we represent them. All right, so scatter plot. Let's get into it. A scatter plot. Okay, have a look at the scatter plot here. Let's look at height and weight, for example. Yeah, what do we see with the data in height and weight, guys? Anything about it that stands out to you? The taller someone there is, the heavier they could be. Yeah, generally speaking, yes. Cool. And what else? What are the 2 variables you're working with? So when we're talking about variables, remember it's whatever is in the x-axis and in the y-axis. So the variables are height and weight. So this graph is trying to show or tell us that there could be some sort of connection to the data. What do you guys think would happen if there was just dots all over the place? What do you guys think that might mean? Is there a connection between them? Probably not, no. So if a graph looks really random, there probably isn't any connection, okay? And that's the kind of conclusion you can come out by looking at a graph. But essentially, when we talk about connection, we're talking about the word relationship. So is there anything that they have that is affecting the other? So does your height affect your weight, or does your weight affect your height? Those are the things that you're trying to think about when you're working with scatter plots. Okay, and let's look at this one here. I don't know if anybody here plays games, but what does this data suggest? Let me ask Francis. What might this data suggest? So what are the 2 variables you're looking at? So what's it on the bottom? Oh. Yeah. What's this variable? Just read it. What does it say?
Oh, the number.
Yeah.
Yeah.
Hours spent.
Sorry, hours spent.
So the variables are hours spent gaming and your test results. Ooh, okay. Junior, can you tell me what does this data suggest? Hours spent gaming versus test results. What is it saying to you?
The hours.
Yep, so how many hours? So the higher the hours, what's happening with your test results? The lower your test results are. So the more hours you spend playing games, the lower your test results tend to be. Okay? Now, again, this is I don't know if this is even 100% true. I found this on the interweb, so it could be true. But that's what it's recording, okay? And you can gather from what Junior said that the more you play, the lower the score. Look at this guy. This guy played how many hours? Nearly 70 hours or 90 hours of video games. Looking at, I'm kidding. And his test result was around 20 or less. Okay?
Oh,
Okay, so that's something to keep in mind when it comes to looking at relationships between variables. Yes. So you're interpreting it, you're looking at it, okay, you got to come up with the meaning of it. Now, there is a certain way, okay, that we do interpret it. You can't just say the more you play, the lower your score. Okay, there's a certain way that you do have to interpret it, and then this is how we interpret it here, or come up with a correlation. So whenever you see the word correlation, this is what you're doing. Okay, you're talking about the strength, and you're talking about the direction. Those two things. You have to include those two, strength and direction. So when I showed you guys this, we have to describe what is the strength, what is the direction. Let's go let me ask, Isabella. Okay, have a think about this. When I say the word positive, which way do you think that goes? Up, good. And if I say the word negative, which way did that go? Down. Okay, so if I was to read this graph left to right, which way does it go? Up. So it is good. Oh, easy. Positive. All right. Elizabeth, what do you think this would be? Good, because it's going downwards. Okay, so when you talk about direction, it's positive and negative. Okay, when you talk about strength, you're referring to how close do the dots how close are they together? So the closer they are, the stronger they become. Okay. Now, strength I find is a little bit iffy because some of you might say, oh yeah, those are pretty close. But I would say this: the straighter the line is through those graphs, the stronger it is. So I would say that this is probably a moderate strength because they're not that close to each other. But you can still sort of see that they're going upwards. This one might be considered strong because they are quite close to each other. Okay, but we'll get into a little bit more detail about that. So when you talk about strength, there's three things. Okay, there's three things you have to mention. It's either weak, it's either moderate, or it's either strong. And we'll look at examples of what that might look like. Now, remember, if I go back to one of the examples here, if I told you that your data, let me see, if your data has dots all over the place and you can't really tell what direction it's going, you guys said there's no relationship, yeah? That's definitely a thing, and we call that no correlation. Okay, if it's just random, no correlation. Okay, that's what your data would look like, no correlation. You guys are doing great, by the way. Okay, and then as Isabella and Elizabeth mentioned, positive is your data goes upwards, negative, your data goes downwards. So those are two things that you have to talk about, the strength and the direction. Let's look at examples of the strength. Now here are some examples, okay? No correlation. All over the place, doesn't make sense, can't really get any meaning out of it, okay? This graph here is considered to be weak. Although they are spread apart, you can still kind of tell which way they're going. Yeah, this looks like the data is going positive. This one here, the dots are a little bit more together, so that means we consider that as moderate, and they are definitely going negative. And strong when they're quite close to each other. So what that suggests, if it's strong, is that there's actually what it suggests for all of them is how close is the relationship between each other. Like say, for example, I wanted to record Mr. Torio's amount of sleep versus amount of food that he eats. Okay, will there be some sort of relationship between them? I would say it's probably something like this. Not really, because what you eat probably doesn't really, or what I eat probably won't affect how much I sleep. Okay, or it could be Mr. Torio's length of hair versus the size of his shoes. Is there a connection between them? Probably not. So your graph will probably look something like this. Okay, so but if I was to say maybe, for example, the amount of exercise you do versus your weight, okay, your graph will probably look something like this because there's probably a connection between them. Okay, so those are the things you've got to think about when you think about connections. All right, direction, really straightforward. If it's going up, it's positive. It's going down, it's negative. Okay, so those are things you have to mention when it comes to correlation, strength, and direction. All right, other examples here. Okay, I can see the correlation for this. I think we looked at this data before, so it's going to be moderate positive correlation because it's not too spread apart, and you can kind of tell where it's going. So for here, you'd say it's moderate, and the direction is going upward, so it's positive, and then you'd include the word correlation in there, okay? For this second graph here, I can see that the dots are quite close to each other. Okay, so it would be strong. It's going downwards, so it's negative, and then you'd include the word correlation in the end. Okay, this is how they want you to answer it in year 11. Okay, I wonder if there's other examples here. No other examples. Okay, pretty straightforward. Let's go here real quick. Other correlation examples here. Shoe size versus IQ. There's probably no connection there. That's why it's random. Okay, your shoe size doesn't determine how smart you are. Because if that was the case, I'd be really dumb. Well, which I kind of am anyway. But anyway, there should not be any correlation between it. But maybe weight versus exercise, like I mentioned. So maybe the more kilometers you run per week, the lower your weight could be. Okay. I did mention before outliers. So here is an example of outlier. So as Jamie mentioned, it's data that doesn't belong with everything else in there. So this is a possible outlier. You just need to make sure you can state what that outlier is. So in this case, the outlier for this would be 790. Now, what does that mean? Okay, it's the coordinate for this, which means that he's walking 7 hours and the weight is about 90. Okay, so that's what that outlier is. I mean, we'll talk about that a little bit more shortly. Okay. All right. How are we going so far? Everyone good? Let's go through some examples, a couple, and then you guys can start working. Okay, so let's do this. Examples. Let's go in this example. So here is an X and Y table. Remember what I mentioned. What they'll get you to do is normally you'll have a table and you need to graph it. Because graphing it is a lot easier to interpret the data after you've graphed it. So in this table, we need to draw a scatter plot, describe the correlation, and then identify if there's any data that doesn't belong, any outliers. All right, let's go to this page. Now, I've already drawn the table for you, so you don't have to. Oh, sorry, the graph. But one thing you need to make sure is make sure you label your axes, so X and Y, whatever X and Y is. So X could be, whatever the variable might be, and then Y is the other variable. You've got to make sure you put it in. Okay, let's draw the scatter plot for it. So the first one is 219. Okay, so 219 would be about here. Make your dots as big, or not too big, but just so it's obvious. Next is 316. Oh, sorry, 36. Thank you. Thank you, Jamie. It's 317. Okay, so 317 is over here. So notice how it's not going to make a straight line. It's just going to be dots in random spots. Okay. Next is 413. So 413. Next, 510. So 510. Then you've got 6, 9. So 6, and then 9 would be over here. 7, 8. So 7, and then 8 would be right in the line. Then you've got 8, 6. And then 9, 4. And then 9, 5. Okay, so make sure your graph looks something like mine. You guys would probably have done a bit of this already in year 9 or year 8. That's good. But it's just good to be able to do this again as a bit of a recap. Okay, so our graph should look something like this. Different from a time series, because we're not measuring time anymore. Okay, this is a scatter plot. Okay, just be mindful of where you put your dots. Okay, does everyone's graph look like this? Good. All right, cool. All right, easy, yeah, that's not that hard. When you draw in your SAC or in your CFAT, make sure you draw your graph like this. All right, let's go to the next one. Identify any outliers, and then let's describe the correlation. Actually, describe the correlation, identify the outliers. Okay, so what's the correlation of this? Remember, the correlation, you're talking about the strength and the direction. So anyone want to maybe take a guess on what the strength could be for this? Yes, Nelson.
Weak, negative.
Ooh, you could say weak. Are you saying it's weak because of this guy here? It makes it a bit spread out.
Yeah.
You could. But let's say we don't include the outlier. Okay. What do you think the strength would be? So remember, the more straight the line becomes, the stronger it is. Yes. It's pretty strong. I would say strong because it almost forms a straight line. That's what we talk about when we talk about strength. So it's strong, but good guess, Nelson. Nelson, let you try this one. What direction is it going? Good. So it's a strong negative correlation. Okay, easy. In year 11, there is a little bit more detail apart from this, but we'll just keep it to this in year 10. Okay. So you talk about strength and the direction. Ecclesia, can you tell me what the outlier could be? So what data doesn't quite belong with the rest of it?
30.
Good. So 3, 6. That's it. Okay, that could be an outlier. 3, 6. Cool. Easy, not too hard, yeah? So this is essentially all you're going to be doing for this chapter is these sort of questions. Let me see. Let me just move ahead. And then we'll do one more example, then you guys can start working. Okay, cool. All right. I'll get you guys to do this one, okay? I want you to do this on your own, and then we'll go through it together in like 5 minutes, okay? There's 4 questions here. The graph is already kind of drawn for you, but you do need to draw, actually no, it's not. You need to draw the scatter plot for it, but try and do it yourself, see how you go, okay, for this. It's similar to the other one that we just did, but see if you can do it on your own, okay? Think about it, you've got 30-year-old people like me who are like shorter than some of you, all right? Or you might have someone like Emma, who's the same age as you, but he's a little bit taller than you. Okay, so if you think about how the dots will spread out, they're actually not that close to each other. It's kind of all over the place. But generally speaking, it makes sense that it would go in a positive direction. You don't really have 80-year-old people who are like 30 centimeters tall. Just like this tall. Now, have a think. What do you think this represents, guys? What does this represent? 30 centimeters tall, 0 age. What is that?
Baby.
It's a baby. Yes, that makes sense. Okay. So be mindful of something like that. See how this variable is on 0? That means right there on 0 where it begins, it's about 30 or 32, whatever it was. Okay. Now, some of you mentioned, are there any values that could be outliers? Jamie and Elizabeth asked me that. They said, are there 2? There could be 2. Yeah. Some might even say there's probably 3. Okay. It could be 1, 2, and 3. Okay. Possibly. But if you at least list out that this height and this height are probably outliers, that they would be correct. So you're looking at 0, 32. And the other one was, what was it? 77,
And
156. Yeah.
Wait, so all in 75 doesn't outline?
I don't think so. Not yet, because technically it's still pretty close to everyone else in that. Yeah, but you could argue that it is. I think if you wrote it on the sack, I wouldn't deduct marks from you because it's kind of misleading. But those are 2 definite ones. Yeah, these 2. Here's a question as well. So before we finish up, why do you think that the person who is like 77 years old is a little bit shorter than someone who's maybe like 40? What happens when you get older?
I shrink.
You don't shrink, no.
Yes.
What happens to your back? It becomes a little bit more that. That's why they get a little bit shorter. Okay, so just keep those things in mind when you do data. Okay, just as a recap. So remember scatterplots, which is what we just drew. Okay, you've got bivariate data in it. Okay, you're working with bivariate data now with scatterplots. And you're looking at relationships between them. In terms of a relationship, remember you're talking about 2 things. What is the strength? What is the direction? And you have to mention what is it out of these. So is the strength weak, moderate, or strong? Or is the direction positive, negative? Now, one thing to keep in mind is if your dots are too random, then there's no correlation. Okay? I'll put that here. dots are random. Okay, so if your dots are just random, and that means there's no correlation. And then outliers, remember, are points that appear separate from the rest of the data. So you just got to make sure you know which one they are and that you list them. Cool. All right, that's it from me. Well done, Banana.